Good morning and welcome back to Algebra 1 with Miss Betsy. Today we are going to be beginning a new chapter where we're talking about polynomials. We're going to talk about how we classify them, how we evaluate them. We're going to see that once again there's a lot of vocabulary involved in the study of math. Now, speaking specifically to my kids in my co-op, make sure that you pay a lot of attention learning this vocabulary, just like it was important, like it was essential to learn the vocabulary related to equations of lines and dealing with linear equations. You just simply have to know this stuff. It's not so hard in here once you learn the vocabulary. So what we're going to be using for our text for this video is the second edition of Algebra 1, published by Bob Jones University Press. The ordering of topics is not the same as it is in the third edition. The content, however, teaches you exactly the same thing, so it doesn't matter what edition you're using as you watch this video, and you could even be using a text published by another publishing house. So let's go ahead and pray, see what my lame joke is, and we'll get into today's lesson, which is actually a very short, easy one. Nice after the two variable word problems you had last week. So Father, we are grateful that you love us, and we are grateful for the way that you are at work constantly in our lives. I ask, Lord, that you would help us to understand the things that you would teach us today, that you would help me to communicate clearly, and that you would be glorified. In Jesus' name, amen. Okay, we're in section 8.1, and it's entitled Classifying and Evaluating Polynomials. So they're just giving you a reminder of the definitions of algebra and showing you how you're going to evaluate things. You remember way back in chapter 3, we talked about what terms were, and that you had like terms and you had unlike terms. Now I'm on page 324 in my text, and it looks like I'm at the very beginning of the book. It's a 2-volume teacher's edition. So they had different examples of what terms could be. Terms could be constants, and constants were just simply numbers. Negative 1/3, 4, 205. These are examples of what we called constants. And they're called constants because just like God, they don't change. 4 is always 4 is always 4. It doesn't matter what the day is, what the weather's like. Constant terms don't change. And then we had variables raised to a power. And we know that variables are letters that take the place of a number. That can be any number depending on the conditions under which you're working the problem. So they're called variables because they change. They do not remain constant. And variables involved a letter raised to a power. So it could be x to the 4th, it could be y to the 2nd, it could be y to the 1st. But when we have y to the 1st, we don't show that 1. And you remember, if you don't, you need to know right now for sure, forever, for the rest of your math career, that what these variables here mean is that you're going to use x, whatever the value of x is here, as a factor 4 times. You're going to use y as a factor twice. You're going to use y only 1 time as a factor. So these are variables. You can also have an exponent of 0. You could have x to the 0 power, but we said that any expression that is raised to the 0 power is always equal to 1. So we don't tend to consider x to the 0, anything to the 0 power, as a variable. That can be written that way. Okay, so we had variables, and then we have the product of one or more variables and a constant. So I'll just put that these are products over here. That could be something that looks like 4x squared. It could be 12 x y cubed z to the fifth. It's any combination of constants and variables that are expressed as a product. Any product, any combination of factors, 12 times x times y squared times z squared. These are what they call terms. And the way that you define terms as being like or unlike, they have to agree in variable and they have to agree in exponent. And the coefficient, which is the number that is directly in front of the term, is irrelevant. So we have 3x, 4x squared, 2x, and 3y. These would be four different terms. We're going to look and see if any of these are like terms. We said in order for terms to be like terms, they have to have the same variable. Well, we've got an x, x squared, and an x. So does that mean that all three of these terms are like terms? No, because they also have to be alike in exponent. So we have only these two variables, these two terms right here, the 3x and the 2x. These are the only ones that are going to be like terms because we have x squared. Now, you can say, but we've got 3x and we have 3y. Wouldn't 3x and 3y be considered like terms because they both have a 3? Well, no, that is the coefficient. The coefficient doesn't matter at all. The number of y's that you have 3 y's. Y plus y is equal to 3y. Has nothing to do with anything. What determines whether or not two separate terms are like is that the variables and their exponents have to be identical. So that's the review of how you deal with like terms, how you classify terms. Now we have collections of terms. I want to show you two algebraic expressions here. We have 2x squared plus 3x plus 5y minus 4x, and we have this is just what I simply showed you already, jumped ahead. This is a collection of terms put together. When you join them together with addition symbols or subtraction symbols, these are called polynomials. And this is from the Latin, poly meaning many. We have many terms in here. How many terms do we have? 1, 2, 3, 4. How many of these are like terms? Only the plus 3x and the negative 4x are like terms because they agree in variable and exponent. This is a polynomial, which is simply a collection of terms. Now we have some little sub-definitions of polynomials, and hopefully this is reviewed to many of you. You have polynomials, you have trinomials, and you have monomials, and you have, whoops, got those out of order, you have binomials, and you have monomial. Monomial. Sometimes I cannot spell and talk at the same time. Poly is many. Look at our prefixes here, tri, bi, and mono. Tri is 3, bi is 2, mono is 1. An example of a polynomial could be, you can have a two-term polynomial. We just specifically call it a binomial. So typically polynomials have 4 or more terms. A trinomial is going to have three terms. 3x squared, negative x, and a positive 3z are the three trinomial terms. Binomials you deal with constantly in algebra. This is a special binomial. It's called the difference of two squares, and we'll learn about this before too long. And this is a binomial. It has two terms, x squared and a negative y squared. And then a monomial, just like a monocular microscope or these little jeweler's loops where you look through one eye. A monomial is just a single term. Now it might be something that looks like it can't just be one because it says 7 and it says we have x squared, but it's a single term. Monomial, binomial, trinomial, and polynomial. And now we're going to talk about the degree of a term, or the degree of a polynomial also. Let's first consider what the degree of a term is. You must be able to differentiate and identify, distinguish between the degree of a term and the degree of a polynomial. The degree of a term is the sum of the exponents in the variable, in the term rather. You can find this at the bottom of page 324. It's the sum of the exponents on the variables. So if we have this term right here, we have 5, I'm just make up one, 5x cubed, y squared, z to the 4th. What does it say the degree of the term is? It's the sum of the exponents on the variables. 3 plus 2 is 5 plus 9. So this is said to be a degree 9. What is the degree of this term? Right here it's degree 9 because you add up all of the variables. It's the part that the guys like as I throw the marker across the room because it's too light for me anymore. Now what if we had a term that looked like this? 6y to the 4th, I shouldn't do it starting there. Well, 6y to the 4th z. What is going to be the degree of this term? It's too early in the morning, my writing is horrendous. Is it 4th degree? Because what we're doing is we're adding up, we're taking the sum of the variables on the exponents, and there's not an exponent here, so should it be 4th degree? No, it's not 4th degree, it's degree 5. And why is it 5th degree? Because when there is not a written exponent, we understand that it is z to the 1st power. So don't forget first degree. You always need to add those in there. So this is how you calculate the degree of a term. And then you also have to be able to determine what the degree of a polynomial is. And I cannot get this book to move for me properly. And the degree of a polynomial is the degree of the term with the highest degree. And you can find that on page 325. So we have the degree of a term, which is a sum of the exponents in that one single term. And we also have the degree of a polynomial. Degree of the polynomial is the highest degreed term. So let me go ahead and write an example here, and let's see what the degree is. We're going to find this with example 1. let's see what we want to do. We have 3x cubed y plus 2x plus 4xy squared. Our question says find the degree of the polynomial. Well, how do we do that? First we have to look at each individual term and figure out what degree it has. How do you figure out the degree of a term? By adding up the exponents. 3 plus the 1 is 4. So this term here is fourth degree. This term here just has one single x, so this is first degree. This term right here, you have x to the first, y squared, so this would be a third degree term. So I'm just going to write up here, this is 4, this is 1, and this is 3. So what is the degree of this polynomial? The degree of this polynomial is the degree of the highest degree term in it. We have a 1, a 3, and a 4. So 4 is clearly the highest degree, and we have a fourth degree polynomial, or a polynomial that has degree 4. And you say, well, wait a minute, you said you added them up, so we have 3, 4, 5, 6, 8, where we go 4 plus 1 is 5 plus 3 is 8. No, it is not degree 8. We have two different ways that we deal with finding degree. The degree of a term is the sum of all of the exponents. So the degree of this term is 4. We added these exponents up. But the degree of a polynomial is the degree of the highest degree term. You're not adding up the degrees of all of the terms in there. You're only taking the highest degree term. That's the degree of a polynomial, and that's very, very important. Well, that was interesting. Literally tore that paper. So now we have to be able to evaluate polynomials. And it is just as simple as can be to evaluate polynomials, but you need to make certain that you follow the rules for order of operation. Way back in the beginning, they asked you to do something that said, evaluate 2x plus y when x is 2 and y is 1. You remember this? You simply substituted in the value of those variables, and under these conditions, the value of this polynomial, which, by the way, is a binomial because it has two terms, was 5. Now remember, we said that we called our letters variables because they're going to change according to how they're defined. This binomial here, 2x plus y, can have any number of values. You know, if x is 2,000 and y is a negative 50, well, you just substitute those values in, and you see that 4,000, 3,950 all of a sudden now is the value of this binomial. Okay? You're going to do exactly the same thing when you evaluate polynomials. Simple. There is no new really work or computation or manipulation for this week. For this section, what you've got to do is work on getting your vocabulary. So let's say that we want to evaluate 5x cubed y plus 2x minus 3y plus 5, and x is going to be negative 2, y is going to be a positive 1. Now let me look and make sure I copied it correctly. 5x cubed y plus 2x minus 3y plus 5, and we have a negative 2 and a positive 1. First, let's decide what this polynomial here is. Is it a, how many terms? 1, 2, 3, 4. We don't have special names for a polynomial that has 4 terms, so this is just a 4-term polynomial. And let's see what the degree of that polynomial is. We determine the degree by finding the highest degree term, and clearly the highest degree term is going to be this one. We're going to add together the exponents. 3 plus 1 is 4. So this algebraic expression here is called a 4th degree polynomial. Now, if we want to evaluate this 4th degree polynomial, we simply substitute in the values that have been assigned for the given variable. And it is very important, very helpful that when you substitute in, that you enclose those values that you're substituting. Go ahead and enclose them in parentheses. It will make it easier for you to be sure that you don't miss a negative sign. Now we have plus 2 times x, and x has a value of -2. Now remember, we have x is -2 and y is a positive 1. So I'm just going to go ahead and erase that little bit of information there. Minus 3 times a positive 1 plus 5. Now you see that I made sure to enclose in variables the values that I was substituting for the variables. So now, follow our order of operations. It says, do your exponents first. -2 cubed is going to be a -8. So we have 5 times a -8 times 1 plus 2 times a -2 minus 3 plus 5. Put as many steps in here as you need to make sure you don't drop a negative sign or miss it. We now have 5 times -8 is -40 times 1. We have -40 plus 2 times a -2 is a -4 minus 3 plus 5. Now do your addition. -40, -44, -47 plus 5 is going to give us a -42. And if you look in your book, you see that that's exactly what our solution is. Nothing new here. The only thing that I would emphasize to you is be careful. Be precise. Watch your negatives. These are not in order of what you should do. Check your transcription. But if you follow these 4 points, you're not going to have a problem doing this homework. First off, when you copy your problem down, check it. Make sure you've written it properly. It's easy to switch negatives to transpose numbers. Make sure you've copied your problem properly and you've copied the values correctly. Be really careful when you're doing this. Be precise and at least neat. Write dark enough so that you can follow what you're doing. Write large enough so that you can clearly see what you're doing. Watch your negatives. The biggest problems that you're going to have doing with algebra just in general is that you have miscopied a problem, or that your negative signs tripped you up. So that's all that section 8.1 is about. I'm sure that you can do your homework in just about the time that it took you to watch this video. Just make sure that you remember the degrees of a term. You calculate the degree of a term by summing the variables, the exponents on those variables. So the degree of this term would be, it's a bizarre degree, but this would be a degree 13. 7 plus 2 is 9, plus 4 is 3. That we have polynomials are the sum or difference of a collection of terms, and you can have, if you just have one term, it's a monomial. I'm not going to take the time to write this down. If you have 2 terms, it's called a binomial. You have 3 terms, it's called a trinomial. 4 terms or more, we just refer to them as polynomials. The degree of a term is the sum of the exponents of the variables in that term. The degree of a polynomial, though, there's no adding together all of the exponents in there. The degree of a polynomial is simply the degree of the highest degree term in that. And just with this little bit of a review that I did right now is throwing all sorts of words around. Make sure that you know what those words are, and this will be a very straightforward section for you. I'll see you next time.